Subscribe and click the notification bell to stay updated with the latest videos from School of Technology, Management and Engineering, NMIMS Indore.
Good evening, one and all present here. I, Rishabh Singh Tomar.
And I, Siddhant Jain from BTech CSBS third year, STME NMIMS Indore, are going to be presenting on the topic Introduction to Machine Learning. Now, during the course of this session, we have also prepared a bunch of questions for you guys, which will keep coming as we discuss the topics. For this, we request you all to go to the link provided in the Zoom chat. Being machine learning enthusiasts ourselves, we are glad to acquaint you with the field of machine learning. In today's session, we will cover some wonderful applications of machine learning, where you will realize that you are all actually already using it, followed by what is machine learning and its types, and finally, for the dessert, we will demonstrate the implementation of a prominent machine learning algorithm. We will use this algorithm to solve a real world problem. We hope that you will find this session fun, engaging, and that you will take out a plethora of learnings from it. Our final aim would be to ignite at least a tiny amount of interest in you towards machine learning.
What if I asked the computer to paint me a picture of an astronaut riding a horse? Well, you'd say nothing interesting will happen because computers aren't creative. Computers can't paint, right? Well, this was the thing of past. This is what an AI agent called DALE 2 created based on our prompt, astronaut riding a horse. Maybe you're looking for something more interesting, like a monkey paying taxes or a monkey wearing a funny hat. You can think of any prompt and DALE 2 will convert it into a photorealistic image that has never appeared before. Research companies like OpenAI and DeepMind are creating numerous AI agents that can create art, literature, summarize your documents, and even write those tedious and boring assignments for you. Sounds interesting, right? All of this is not directly machine learning, but it all started with machine learning.
Now, let us take a look at some of the applications of machine learning. You might not know, but machine learning is used everywhere around us. For example, personal assistants like Google's Assistant, Amazon's Alexa, Microsoft's Cortana, and Apple's Siri. We have all used some of these at some point in our life. For example, you can tell them to call someone, or you can tell them to play music, or even schedule an appointment. These assistants are powered with the help of machine learning algorithms. They record what you say and they send it over to a cloud server. And then the server decodes the message using machine learning algorithms or neural networks. And then they send the output back to you. The second application is targeted advertisement. So let's say that I want to buy an iPhone. So I go to Amazon and search for an iPhone. The latest one is iPhone 13 Pro, but I can't buy it at the moment because it is too expensive. But the next time I'm on Instagram, I'll see an advertisement related to an iPhone. And so will I receive an advertisement if I go to Facebook or YouTube. Now, with the help of a machine learning algorithm, Google has understood that I am interested in buying an iPhone. And therefore, it is recommending me the product with the help of advertisements. This is called personalized or targeted advertisement. The third application is healthcare and medicine. Medical technology has innovated with the use of machine learning to diagnose diseases. We were able to analyze 2D CT scans and come up with 3D models that predict where exactly there are lesions in the brain. It works equally well with brain tumors as well. The applications and benefits of machine learning are countless, but let us move on and understand how this magic actually works.
In today's era, data is not just power, but also the new currency. And those who understand it properly may well become the next Jeff Bezos. For our purposes, we'll define machine learning in just 5 words, using data to answer questions. In particular, we can split this definition into 2 parts, using data and answering questions. These 2 pieces broadly outline the 2 equally important sides of machine learning. Using data is what we refer to as training, while answering question is referred to as making prediction or inferences. We can drill deeper into those 2 sides briefly for a little bit. Training refers to using our data to inform the creation and fine-tuning of a predictive model. This predictive model can then be used to serve up predictions on previously unseen data and answer those questions. This is how almost all of the machine learning solutions work. They train on some data and then they used that training to predict or classify new data.
Now, let us take a look at the types of machine learning. Primarily, machine learning is of three types. The very first one being supervised machine learning. As the name suggests, you have to supervise your machine learning while you train on it to work on its own. It requires labeled training data or a training data that has some output variable in it. The second type is the unsupervised machine learning. In unsupervised machine learning, there will be training data, but it won't be labeled. The third type is reinforcement learning. In reinforcement learning, the system learns on its own. Now, let us explore each type in detail, starting with supervised machine learning. To explain it, let the monitor represent our machine learning model. Now, initially, we feed in the data to the system. This is called the training data. We give our system a datasets of images of a fruit, and we also give it labels telling it that this fruit is an apple. The model then finds patterns in the dataset, and then after the model is trained or after the training phase, we can give new data to our model, and it will correctly predict it as apple. But what if we input an image of an orange? The model will be able to tell that this fruit is not an apple, but it won't be able to tell that it is an orange. This is because a model wasn't trained to recognize oranges or any other fruits other than apples. This type of machine learning model is used in email spam filtering to filter out spam emails from non-spam emails.
Next up, let's see what is unsupervised machine learning. Let's say we have a data set containing a number of fruits and the data set is clustered. We feed this data to our model analyzes it and finds patterns from the data. After it is done, it categorizes the data set into three types based on the types of their similarities as illustrated on the screen. In this type of learning, you provide data to the system and let it do the rest of the work. Simple, isn't it? This type of model is used by e-commerce websites like Flipkart and Amazon to find products that are well suited for you. The next is the most interesting one and one of my favorites. It is called reinforcement learning. This is the type of learning that is shown in most sci-fi movies. Before we understand this, using our Apple analogy, I want you all to imagine an infant. What will they do if you put a candle in front of them? Well, they will touch it and harm themselves, right? But the next time you put a lit candle in front of them, they will not touch it because they have learned to not touch a lit candle from their past experiences. Similarly, we train our models to learn from their past experiences. Let's say we ask our model to identify a fruit. In this case, we have an apple. The model doesn't know it and it guesses it as a mango. Then we give it feedback that no, this is not mango, it is an apple. The model learns from the feedback and remembers it. The next time we ask about an apple, it can correctly respond by telling us that yes, this is an apple. And this is how reinforcement learning works.
To solve any problem, we use an algorithm. Algorithms in the simplest sense are nothing but steps and methods to solve a particular problem. Algorithms are not machine learning, but ways to solve a machine learning problem. The very first kind of method that we will discuss is classification. Classification comes under supervised learning, and it is used when the output you are looking for is either a yes or a no, or in the form of two labels, which is A or B, or true or false. For example, if a shopkeeper wants to predict if a particular customer will come back to the shop or not, it will fall under classification. Some of the algorithms that fall under classification are decision trees, naive Bayes, random forest, etc. The second type is regression. Regression is used when the predicted data is numerical in nature. Like if the shopkeeper wants to predict the price of a product based on its demand, the problem will fall under regression. Some of the algorithms that fall under regression are linear regression and ridge regression, etc.
The last type of method is clustering. Clustering is kind of an unsupervised learning algorithm. It is used when the data is needed to be organized. Most of the recommendation systems used by Flipkart, Amazon, Myntra, etc. uses clustering. Another major application of clustering is used in search engines. The search engines study your old search history and try to figure out your preferences and provide you with the best search result. Some of the algorithms that fall under clustering are K-means algorithms and DB-scan.
Now, keeping the types of algorithms in mind and when to use which one, we have a question for you all. The question is, suppose you are working on weather prediction and you would like to predict whether or not it will be raining at 5 p.m. tomorrow. You want to use a learning algorithm for this. Would you treat this as a classification problem or a regression problem? You all have 30 seconds to answer this question. You'll have to go to the tab that we told you to go to earlier. Looks like only 44% of you could correctly classify it as a classification problem. Now, the correct answer is classification because we want to predict whether it will rain or will it not rain. So there are two labels.
Now, before we start with the hands-on session, let's understand what is the problem that we are trying to solve and what are the ways and in which we are going to solve that problem. In this demonstration, we are trying to solve the problem of spam detection. We all receive messages from friends, families, and we also receive spam emails, which are unwanted messages that are usually scams or unsolicited advertisements. Now, the problem at hand is to classify whether a given message is a normal message or a spam message. So let's see how it can be done. As we have seen, every machine learning solution is based on data. For this problem, we will collect a lot of email data. We label them if they are spam or not spam. To solve this problem, we are going to use the supervised learning model, which is naive Bayes. But before moving to the code, let's understand how naive Bayes works. And let's say we have 12 messages, 8 of them are normal message and 4 of them are spam messages. We first make a histogram of all the words that occur in a normal message and we calculate the probabilities of them occurring in a normal message, given that we are looking in a normal message. We do the same for the probabilities with the words occurring in a spam message. Now, let's say we get a new message saying, "Dear friend." We start with an initial guess about the probability that any message, regardless of what it says, is a normal message. This guess can be any probability that what we want, but a common guess is estimated from the training data. For example, since 8 out of 12 messages are normal message, our initial guess will be 0.67. This is called the prior probability. Now we multiply the initial guess by the probability that the word dear occurs in a normal message and the probability that the word friend occurs in a normal message. So after we plug in the values and do the math, we get the score of 0.9. This is the probability that that the message dear friend get if it was a normal message.
Now, just like we did before, we start with an initial guess about the probability that any message, regardless of what it says, is spam. Now we multiply that initial guess by the probability that the word dear occurs in spam, and then we multiply the probability that the word friend occurs in spam. And we plug in the values and we get 0.01 as the score. This is the score that the message dear friend gets if it is a spam message. Clearly, the likelihood of dear friend being a normal message is more than the likelihood of dear friend being a non-spam message. Therefore, we classify it as a normal message.
Let's look at a bit more complex situation here. This time, we are trying to classify this message, lunch, money, 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 money. This message contains money 5 times. The probability to see the word money in a spam message is much more higher than that to see it in a normal message. Then it seems reasonable to predict that this message will end up being a spam message.
But there's a catch. This message contains the word lunch, and the probability of seeing the word lunch, given that we are seeing a spam message, is 0, since it was not in the training data. Now, it doesn't matter what the probability is that we see money given that the message is spam, because anything multiplied by zero is zero. In other words, if a message contains the word lunch, it will not be classified as spam. That means that we will always classify the message containing lunch as a normal message. To work around this problem, people usually add one count to each word in the training data. Now, if you open up the dataset that we provided in any of the text,
the very first column is the label telling whether a message is spam or ham, which is just a fancy way of saying whether a message is spam or not. The second column is the email message itself. And now comes another question. What is a CSV file? 56% of you correctly guessed it as a file which is used for storing information where values are separated by a comma. This is the format that our dataset is in. Now we know that you all are getting very excited for the coding part to begin. But just one more concept before we dive deep into our Python notebooks. Machines will not understand the text as it is, right? Because machines work on zeros and ones. And therefore, we will have to convert these messages into zeros and ones before we can write the code to process them. This step is called data pre-processing.
The first step is to tokenize the message. As the example on the screen suggests, in tokenization, we break the entire message to its smallest parts or tokens.
The second step is to remove the clutter. Clutter could be things like punctuations or URLs or stop words like the, that, them. These are the words that don't really have a lot of information in them.
The third step is to lowercase our tokens. Now, why do we have to lowercase our tokens? Because our model will treat a capitalized text different than a lowercase text. Therefore, to have uniformity, we lowercase our entire tokens.
The fourth step is to stematize or lematize the message. In general, to break down the token to its root level or to break any word into its root form. For example, the word submission will get broken down into submit. Similarly, the word entered will get broken down into enter. Stemming or lematizations are the ways that allow us to break the words down.
Moving on, the final step of our pre-processing is vectorization. For vectorization, we use a concept called bag of words. Bag of words count all the instances of a token in a given observation, and we get a matrix representing how many times that word appear in our message. For example, in our pre-processed token, the token write up one time, algorithm appeared one time, submit appeared 2 times, and contest appeared 2 times. And similarly for the rest of the tokens. After this process, we get a huge array or a huge matrix or technically vector representing numerically how many times a message appeared in the sentence. And we can use this to feed it into our model and then get predictions about it.
And that was all about the theory part. Now we will move to the demonstration part. Before moving on, we hope that you all have uploaded the provided notebook into Google Colab, the one provided in the prerequisites folder. Now I hope every person has uploaded their Google Colab notebooks so that we can proceed with the demonstration. Now that we have given you plenty of knowledge, it's time for some wisdom too, because knowledge becomes wisdom only after it has been put to practical use. Keeping that in mind, let us move on to the demonstration of naive bias. Now, in the very first cell, we have imported all the required libraries that we will use to create a model. The very first library that is to be used is pandas. Pandas is used to load the dataset and also to modify and view our dataset. The second library that we are going to be using is NLTK. We will use NLTK to pre-process our dataset. And then finally, the third library is scikit-learn. We will use scikit-learn to create a model. Additionally, we will also download some of the NLTK datasets. These datasets will help us in the pre-processing part. Please run the very first cell so that it will import all the libraries. Now moving on to the dataset. Our dataset has a name called spam. You can find it in the prerequisites folder that was shared with you. Now, you can also find this dataset in your prerequisites folder. Once you have downloaded the dataset, you will have to upload it to your Google Notebook. To upload it and also to answer Yash's question, you can click on the very left. You will see this files icon on the leftmost part of your notebook. You will have to click that. And then you will, this section will pop up, and below files, the very first icon, click on that. Now you will have to locate where you have downloaded your dataset and simply double click it. And it will upload it to your Google Notebook. Once you have uploaded the dataset, you will have to load the dataset. You can find it. Now we use the we load the dataset and we store it in the form of a pandas data frame using the following code snippet. Please follow along. We define our variable as df, and then we do pd.read_csv function. And as a parameter to the read_csv function, we pass in the path to our dataset. For our use case, the path is simply spam.csv. Now run the data and run the cell.
After that, we have imported our data set as a data frame. We will see statistical information about it. To do that, we will write the following command, df.head. This function will show us the first 5 rows of our data set. As you can see, the first label contains what type of email it is. Either it is a ham or a spam. And the second column contains the email body.
Now we have another question for you all. Given the dataset, what is the most suitable type of learning that is to be used for this use case? Supervised learning, unsupervised learning, reinforcement learning, none of the above. And 86% of you correctly guessed it as supervised learning. And it is indeed the correct answer because our very first column is label and it has 2 classes, either ham or a spam. And therefore it comes under a labeled dataset and the learning is supervised learning. df.shape, we were exploring our dataset and we had already explored df.head. The next function is df.shape. Simply write the name of the df, simply write df and then dot shape. And then you will have to press the play icon and it will run the cell for you. df.shape returns the number of rows as well as the number of columns that are present in our dataset. As you can see, our dataset has 5572 number of rows or number of records, and it has 2 columns.
Now to know our dataset a little bit better, you can use the function df.info. This tells us information about each column present in a dataset. Now, if you run this, you will get information of our columns. So as you can see, the first column is label, which has 5,572 values, and all of them are non-null. And these are object type values. And similarly, second column is email text, which also has 5,572 values. All of them are non-null and object type.
Now we got lucky that our dataset doesn't have any null values, but it is always an important step to check if there are any null values present in your dataset. To check the count of null values, you can use the function df.isNull, which is ISNULL, and then followed by dot sum. This function returns the number of null values present in each of the column. For example, the column label doesn't have any null values, and so does email. But if there are any null values present, you will have to deal with them, because null values can highly hamper the performance of any machine learning algorithm. The easiest way to deal with null values is to simply drop any of the records that have a null value. To drop those records, you can follow the following code snippet. You do df equals to and follow the function df dot drop na, and this will drop any of the records that have null values present in them.
Now that we have explored our data, let's move to the second step, that is data pre-processing. As we have already discussed, we need to pre-process our data in order to make it machine understandable. We have already applied two functions to pre-process our data, and you can write the following line of code to pre-process our entire data set. So this statement will take quite a while to process, but until then, we have a question for you all. So the question is, which of the following is not a pre-processing technique in natural language processing? Option A is converting to lowercase. Option B is removing punctuations. Option C is removal of stop words. And option 4 is sentiment analysis. You can go to the same slide or link to answer the question. As most of you has correctly guessed, sentiment analysis is not a pre-processing technique followed in natural language processing.
And now comes the most exciting step: creation of the model. We will begin the creation of the model by firstly defining our input variables as well as our output variable. To define our input variable, let us call it x. And our output variable, which is all the labels of our first column, which is all the values present in our first column, which is label. The next step would be to split our data into two parts. The very first part is called the training data, which will be used to train our model. And then the second part is called testing data, which will be used to evaluate the performance of our model. To split your data into two parts, training and test, please follow the following code snippet. We use the function train test split. And as parameters, the very first parameter that we pass is the input variable. The second parameter is the output variable, which is y, followed by the test size, now the test size is how much percentage of the total data set that you want to give to the test data. In this case, we will give it 33%, and therefore our training data will comprise of 67% of the total data set. And the next step would be to vectorize our input variables. For this, we define a count vectorizer and use the function cv.fit_transform. And as input parameters, we pass in the x_train. To train a model, model.fit is an important step. Use the fit function, and as the first parameter, you pass the counts variable, which you got from your count vectorizer. And as the second parameter, you pass in the y_train.
We will now get the predictions and check the accuracy of our model. And for that, we'll write the following line of code: model.predict
moving on, once you have trained the model, you can also define an example. And then what you need to do is, if you pass in this example in your model, it will try to predict it as a spam or non-spam. The very first line is transforming this code or this email that you've got into a vectorized product, and then you were passing in that as in the model.predict function, and the storing whatever prediction that the model got in the prediction. As you can see, the model correctly predicts it as spam.
That was it from our side. We hope you found this session useful and you were able to derive meaning out of it. We hope you enjoyed the demonstration as well. If you still have any doubts regarding the code or anything related to the session or Python in general, you can reach out to either of us on our emails. We will try our best to rectify errors. Thank you.